Hello, everyone. So we should get started. Is everybody ready? Okay. Um, Before we get started, I want to do a brief introduction regarding myself. My name is Jonathan Zhuo. I'm a Google Cloud Specialist Lead and a Deloitte Certified Chief Architect. Based out of Atlanta, Georgia, I have over 27 years of industry experience as a technology executive. Since Deloitte is a Google Cloud Platinum partner as a hands-on Google Cloud Enterprise Architect, I'm in a unique position to deliver unparalleled expertise and guidance to our clients, helping them unlock the full potential of the cloud. Outside of work, I'm an empty nester and enjoy spending my free time traveling, learning, and educating the next generation of architects. It brings me the great joy to guide and watch them flourish as the next wave of architecture leaders. So for today's presentation, I'm going to talk about choreography versus orchestration in microservice architecture. I want to do a survey to see how many of you are using microservice-based architecture. Please raise your hand. Quite a lot. All right, and how many of you are using messaging services in your architecture design? Still quite a lot. And any of you are using cloud-based, or maybe not cloud-based, we just say workflow in your microservice-based architecture design? One, two. All right, still quite a lot. All right, I think this is a good audience for this talk. For today's presentation, I'm going to start with the problem statement. And then I'm going to talk about two high-level solutions. And then present two different architecture design patterns. At the end, when time permits, I'm going to do a demo. And we will have Q&A sessions before the demo. So if you have some questions, feel free to put into the chat window, and I will address at that time. So we can start with the problem statement. In a modular monolithic application architecture, application is able to rely on a single database ACID capability to recover from failures and guarantee consistency. However, in microservice-based architecture, an end-to-end transaction might span multiple services, and each service might have its own independent database. You cannot rely on the transactional features of a single database to recover from failures and guarantee consistency. Instead, you must implement a transactional workflow in your architecture design. So in the high level, we do have two different architecture solutions. One is called asynchronized choreography-based Saga via messaging service. And the second one is called synchronized orchestration via workflow. Let's take a look at the first architecture design pattern. And how does the asynchronized choreography-based Saga and being utilized in architecture design? I'm going to use simple e-commerce use cases. Here, as you can see, a client submitted some order, and I have an order service. And this order service will put your request into order database. And at the meantime, I also have a customer service. And this customer service microservice is also on the other side, and it's recording your order with the reserved credit to see whether your order has exceeded the credit limit or not. And physically, so that's a logical view. And if it is, let's say the order is not exceeded the credit limit, then order will be placed as accepted. The status will change from pending to accepted. However, on the other side, if the order is exceeded the credit limits, this order will be rejected. That's just from business perspective, and I presented with some logical view perspective. Physically, I'm going to later on have a demo, and also this diagram is showing all of my microservices are deployed in Cloud Run. If you do not familiar what is Cloud Run, it is just to think about it, it is a serverless Kubernetes, and based on Knative spec. And all the database I'm using currently is called a Google Native Data Store. Data Store is a NoSQL DB and support ACID. In the meantime, when I communicate my event, like an order event, into the other side of the customer service, I will go through a messaging service. And physically, here I'm using Google Cloud Native PubSub. And I have a two different topic. When the event happened, or the event happened, it will publish this event into PubSub topic, and then push this notification to customer service. And the customer service will processing your order, say reserve a credit. If it is not exceeded a credit limit, it will send the message back into another topic, and then message will be pushed into order service. So order services can mark your order from pending to accepted. If your order is too big and exceeded your credit limit, the message will also comes back. So your order will be changed. The order status will change from pending to rejected. So that is the business scenario, logical and physical view about this architecture design. To make it robust, the order and the customer service stores event in the event database at first. Then stored events are published periodically through Cloud Scheduler. And the Cloud Scheduler invokes the event publishing service to publish events. And as you can see, the event publishing service also deployed into Cloud Run, which is serverless Kubernetes. And event database is also using Data Store, which is Google Native, NoSQL DB, but it supports ACID transaction. Overall, when a service changes the status of its own entity, it publishes an event to notify other service of updates. The notification events trigger other service to act. In this way, multiple services work together to complete a transactional process. The communication between microservice is asynchronous and loosely coupled. However, I guess you also sensed a little bit of a complex dependency. Let's further zoom into this design, and you can see the modification of data and the associated event data are conducted in an atomic way using the transactional feature of the backend database. Later, the event publishing service, which is here, in this example, periodically scans the database and publishing events with which the published column is false. After successfully publishing an event, it changed the published status column to true. And on the customer service side, it also do the same thing. You have customer database also in conjunction with the processed event database. It will, every processed event will be stored into this processed event database as well. There are some best practices. It is a best practice to enable the data letter topic configured for each PubSub subscription. It allows PubSub to forward undelivered message to a data letter topic to unblock the source topic. If message ordering is important, for example, order request should arrive earlier than cancel request, you should enable message ordering with an ordering key. forgot to. And in this particular case, I did not have create anything called order cancel request in our scenario to keep it simple. But if you do have these kind of needs, you need to have a messaging ordering in place. And also, if exactly once delivery is important, you should change the subscription delivery type from push to pull and enable exactly once delivery. Once enabled, message sent to the subscription are guaranteed not to be resent before the message's acknowledgement deadline expires. And acknowledged message will not be resent to the subscription. So that is the first architecture design pattern using asynchronized choreography through messaging service. The second architecture design pattern is called synchronized orchestration via cloud workflow. As you can see, the cloud workflow is a fully managed service. It handles the orchestration of tasks, microservices, and APIs. It simplifies error handling, and it is global visibility. And in this architecture design, you can see same business scenario, but here I have order processing service in front of everything. And when the request comes into the order, and this order processing service take the request and execute a workflow. And this workflow is called order workflow, and it invokes APIs to process workflow, initially called order services. And order services put your order into the order database, and in the meantime also invoke customer service to reserve the credit. And if the credit is not exceed the credit limits, it will be reserved. Otherwise, it will notify the order service the order is too big and cannot be placed. So order services will change your status to rejected. Otherwise, your order will be accepted. So you use workflow as an orchestrator, and workflow is a managed service that orchestrates and automates Google Cloud and HTTP-based API services with serverless workflow. Communication between microservice and workflow are conducted in a synchronized way. And if you have a very complicated, now keep in mind the workflow is used for flow control. If you have a complicated business logic, the best practice, the best places to put them is in your service, not in the workflow. And the workflow not only orchestrates the process steps, but also seamlessly recovers from errors those steps may encounter, and handles necessary retries or exceptions thrown by APIs, and improves application reliability. It uses declarative API calls, transform from code to YAML or JSON configuration, significantly cut down needed code. You can easily monitor workflow executions, just like this, if you see this screenshot. And that is, we can conclude this, what we discussed today. So in general, we talked about two different architecture patterns. One is a choreography-based saga. It gives you the loose coupling. This approach makes each service more independent. And there's a lower chance of the need to modify services when you introduce new services to the flow. You can change services independently and scale services independently. It is not expecting all services are up and running, more tolerant on service availability. And the downside is complex dependency. It can be complex to understand the flow, This approach might introduce complex into future design changes and troubleshooting. It is also difficult to monitor. No service to ensure success of whole transaction. The second one we talked about is a synchronized orchestration. And it gives you the benefit is simple dependency. As you can see, a single orchestrator controls the whole execution flow of a transaction. It is simpler to understand how the transaction flow works. This pattern simplifies the modification of workflow and the troubleshooting. But also it introduced a risk of tight coupling. The central orchestrator depends on all of the services that make up the transactional workflow. When you modify service or add new services to the workflow, you might need to modify the orchestrator accordingly. Now, which pattern to choose? Both are viable options. Some company already choose the set the choreography-based Saga via messaging service as a standard. You should continue to do so. And some companies already leaning towards using synchronized orchestration through workflow. And you should also stick with this kind of the design pattern standard. When everything is equal, however, because of the simplicity of this design, synchronized orchestration is often my first choice. Now, I'm going to pause here to see any questions you guys have, and before we jump into the demo. Let's see any questions you guys have.
Yeah, I just have a question. So what do you mean on control visibility for simple orchestration? As well as for microservice of microservice for people
that could be the maybe I will answer your question in two pieces. You said global visibility, right? Global visibility in general, you can see your entire workflow is how does it orchestrated on which service, invoke which service, and so on. So in a single place, which is the workflow, the YAML configuration file or JSON configuration file give you a clear snapshot. And even in your, let me see in where, there is another place. Let me see, where is I missed one slide. Oh, there is a one diagram also showed you. One side is the visualize, how does the workflow look like? Weird. That is what I mean in the global visibility. And also through the monitoring, you can see how is the workflow execution results looks like. Different microservice to different data center. Okay. First of all, microservices are Google managed, and it's not residing in your customer VPC. It's a Google managed VPC. Second is that because it's a serverless, and the Cloud Array is also serverless. So when you deploy Cloud Array also at the same thing, is a Google managed service. So it's not reside in your customer VPC. And both of them in Google managed service VPC environment. And the workflow orchestrate, invoke which service, and so on. So, and that's what I mean in the you have a global visibility through single workflow. You can see how does it invoke which service and so on. So, yeah, And if you have, let's say, if I'm not using your cloud workflow always managed by Google, so it runs inside Google's managed VPC. If you have, let's say, you have a Kubernetes runs on your customer VPC, you can still do that, and they will be able to invoke your as an orchestrator to invoke your microservices resides in even your customer VPC environment. Yeah. Any other questions before we jump into a demo? No more question? All right. Yeah. Let me stop sharing this piece and then sharing another screen. Sorry. Hold on a second. Actually, I still want to share this screen in here. So before we jump into the demo, and I'm going to do a demonstration using this sample application. And this sample application has two different architecture design. On the left side, as we already talked about, is the choreography, asynchronous choreography design patterns through PubSub. And on the right side actually is the orchestration, synchronized orchestration through cloud workflow. And we can do a comparison to see, for example, complexity or asynchronous versus synchronous, and so on. So, all right, let me share my. All right, are you able to see my? Yeah, stop sharing. Let me sharing this screen. It's are you able to see on my? Okay, I can do this way. I can do. Yeah.
Maybe you can see that on the screen.
Let me do this.
You can use my laptop.
So your laptop right now is the WebEx actually is how do I do stop sharing? Okay, let me stop sharing on here, and then I'm going to do is
Just one and choose.
Yeah. Yeah, this one. That's okay. Let me do this. Let me share my entire screen maybe. My entire screen is this one, right? So is possible I can share screen to. Are you able to? Is this? Are you able to see it? All right, cool. So in this demo, first of all, we are going to. I'm going to demonstrate asynchronized choreography-based Saga, and as you can see, I already deployed asynchronized order service and asynchronized customer service. and even event publisher into Cloud Run. As I said before, Cloud Run is, you can think about as a serverless Kubernetes and managed by Google. It's based on Knative specification. Second is that I have a data store created. It is a NoSQL DB, Google Cloud Native NoSQL DB data store, and it supports ACID. And then I have a Cloud Scheduler. It's scheduling every minute to scan your event table and then to push the event into PubSub topic. And after that, you can see I have two topics has been created. One is called order service event topic, and another is customer service event topic. So order service event is that once you have something event happened on the order side, it will send into PubSub topic called order service event. And then later on the notification will be posted into customer service. And the customer service event topic is another topic is to the other way, is for customer service to send a message into order service. And in addition to that, each topic has a subscription. One is called push order to customer, another is called push customer to order. And initially, I invoked this API HTTP call with this authorization bear OIDC token. And then I placed a 10,000 credit limit in my customer 01. And at this moment, I reserved 0 credit. Later on, I invoke another HTTP services call to order service. And at that time, also, I'm using authorization with a bear token to giving OIDC identity token to invoke order service and then provide an order into it. And at this moment, you can see the status pending. And later on, if you look at the event entity, you will see on the one side, the event has been published from the order to the order service event topic. But on the other side, customer service event topic, the event has not been published yet because the customer service side needed to process it, reserve credit, and etc. to evaluate whether it is exceeded the credit limit or not. Once it's finished processing, it will send it back, and then you can see the status will in this event table will becomes true, means published. And indeed, in this case, this small order has been changed from status from pending to accepted because all the service indicate I can reserve credit for you. And at the meantime, if you look at the customer service, I have 1,000 credit has been reserved. And if I'm doing another order, which is a big order, at this moment, you can see I placed another big order in order service API through HTTP call. And the status currently is a pending status. And if you look at the event table, 3 of the event has been processed except 1. This one is waiting for customer service to respond. Customer service needs some time to process and reserve your credit. If credit is too big and exceeded credit limit, it will send a message back, and so order can be rejected on the order side. And indeed, in this case, the order has been rejected because it's too big, exceeded the credit limits. So that is actually there's another aspect called a process event. You can see we total have a 4 processed event in our entity. And since we placed 2 orders, and each order has 2 event will be sent from order to customer and customer to order. And 2 orders total, you have 4 events. They are all being processed. So that is the demo regarding asynchronized choreography through PubSub messaging service. Next, I'm going to do another demo, which is leveraging our cloud workflow. Cloud workflow, actually, in this scenario, I already placed actually, I have deployed 3 services: synchronized order service and synchronized customer service and order processing service. Order processing service is the first one in line. Any order comes in, it will take the request and then invoke the cloud workflow. And the cloud workflow will invoke each API, order service, or customer service. So here is the diagram. You can see this is the YAML configuration file on this cloud workflow. And here's my order workflow. And then you can see in this side is the code, the workflow engine showed you. This is the YAML configuration regarding each step by step. On the other side, you can see there's a visualization. It tells you, here's the workflow looks like. Initially, it places an order and then reserve credit and then update your order. Either reject such an order or accept such an order. At the end, mark it as a finish. And we can do the same thing initially through this HTTP services call to invoke customer service and inject 10,000 as the initial credit and with 0 credit reservation. Later on, place a small order through order services API call. And at that time, you can see the status immediately becomes accepted. The reason it becomes accepted is that the workflow orchestrates not only order service, but also the customer service. And because it's not exceeded the credit limit, and so the order is marked as accepted immediately. And then in the customer service, again, you can see the credit now is reserved as 1,000. Still, you have quite a lot of credit limits. It's not far from reach the credit limits yet. And later on, I placed a big order, and this big order being rejected because the customer service cannot secure the enough credit limits. It already exceeded the credit limits. So it will notify customer service this one needed to be rejected. And at the end, you see the entire workflow. We have placed a 2 order. So each order has one workflow for each, and two orders has a 2 workflow. They are all marked as successfully being finished and show in the screen. That is the end of this demonstration. We compared both scenario, and hopefully you can get some sense regarding which one you're more leaning towards, or which one, what's the pro and con from each design patterns, and which one in your mind in the future for your design. I'm going to stop the sharing and to see any questions you guys have.